Hello and welcome to Podcast.init, the podcast about Python and the people who make it great. When you're ready to launch your next app, you'll need somewhere to deploy it, so check out Linode. With private networking, shared block storage, node balancers, and a 200 gigabit network, all controlled by a brand new API, you've got everything you need to scale. Go to podcastinit.com/Linode to get a $20 credit and launch a new server in under a minute. Finding a bug in production is never a fun experience, especially when your users find it first. Airbrake error monitoring ensures that you will always be the first to know, so you can deploy a fix before anyone is impacted. With open source agents for Python 2 and 3, it's easy to get started, and the automatic aggregations, contextual information, and deployment tracking ensure that you don't waste time pinpointing what went wrong. Go to podcastinit.com/airbrake today to sign up and get your first 30 days free and 50% off 3 months of the startup plan. To get worry-free releases, download GoCD, the open-source continuous delivery server built by ThoughtWorks. You can use their pipeline modeling and value stream map to build, control, and monitor every step from commit to deployment in one place. And with their new Kubernetes integration, it's even easier to deploy and scale your build agents. Go to podcastinit.com/GoCD to learn more about their professional support services and enterprise add-ons. And visit the site at podcastinit.com to subscribe to the show, sign up for the newsletter, and read the show notes. Your host as usual is Tobias Macy, and today I'm interviewing James Campbell and Abe Gong about Great Expectations, a tool for testing the data in your analytics pipelines. So, Abe, could you start by introducing yourself?
Sure. I am a data scientist, data engineer, currently the CEO at a new company called Superconductive Health. I'm excited to be here.
And James, how about yourself?
Hi, I am a researcher at a government-sponsored lab called the Laboratory for Analytical Sciences. I would say that I'm very interested in all sorts of the engineering aspects of data science problems in particular. I have gotten to work across a pretty wide range of problems, mostly in the national security space, from cybersecurity to political modeling.
And Abe, going back to you, do you remember how you first got introduced to Python?
I first got introduced to Python in grad school at the University of Michigan. I was doing a bunch of, my dissertation was mining the political blogosphere for civility, which was kind of a boring topic 10 years ago. And it wasn't 10 years ago, 6 years ago. It's a boring topic 6 years ago. It's more interesting now. And I needed a lot of glue code just to hold everything together. Python was the best language then, and I still think the best language now for doing that kind of thing.
And James, how about you? Do you remember how you first got introduced to Python?
I don't remember what the first project that I worked on in Python was, but I think for me, I would definitely say that I came to Python because of its libraries. I think that's been true for a lot of the analytics projects where I've worked, that the language has sort of been secondary to the ecosystem that was available for writing with it. And so for me, I think the availability of libraries like Pandas and Scikit really opened up the use of Python in a variety of projects.
This is the XKCD import anti-gravity thing.
Exactly.
And as I mentioned at the start, we're talking about the project that you have both been collaborating on and recently released called Great Expectations. So I'm wondering if you can just give a high-level overview of what the project does and what was your inspiration for creating it.
Sure. I think it's a fun question because I think Abe and I have known each other for a long time, but we've never actually worked together before this project on anything super substantive. And I would say we sort of came at it from slightly different directions, but really had this moment of realization that we had very overlapping goals and interests. For me, I was leading an analytics team where we were developing a variety of analytics that we were sharing with other teams in our organization. And what I realized is we often had built our models around some pretty deep assumptions about the kinds of data that were going to be used with them. But when we shared the models, it could be difficult for someone else to really understand in a deep way all of the assumptions that we had sort of baked in. And so I was looking for a way to make it easier for people to express the assumptions that they had about data and really clarify those expectations in a way that could be shared across teams and make that collaboration happen more smoothly. When Abe and I were sort of talking about things, I think he was approaching it maybe from a different perspective. Abe, I should let you just describe that.
Sure. So I was coming off of a stint as the chief data officer at a really exciting medical technology startup. And we had been doing these like large scale ongoing data integrations against all of the insurance companies, major insurance companies in the US. And insurance companies are not famous for having really great data systems or data quality. And we just spent a ton of time trying to make these systems flow together, like normalize the data and make sense of it, be able to run consistent queries across lots of platforms. It's just been a massive headache. And I've realized that we needed this abstraction to describe, like, what is it that we expect from our upstream data providers at each point. So, I mean, the exact same set of concerns that James is describing as kind of analytic integrity, understanding what the data is going to be used for me, were really important from a productivity standpoint, to understand, like, how do we not waste weeks with each time we do an integration? How do we make sure that it just works each time?
And what are some of the complexities that are associated with being able to test analytics pipelines and ensure that the integrity of the data remains solid as new systems are built or as the source data maybe evolves?
I love that question because I think the really greatest complexity from pipelines is that they are incredibly interdependent. That's a lot deeper, though, than at the level of a data source or different data sources that we're merging together. There's a lot of interdependence that comes with teams and people because of the active selection that individuals are making at different points in terms of what data to collect and introduce and how it's going to be modeled at different places. When we have that interdependence, what we really want is that there's a lot of change, because that's the way that we're learning and improving our system and models. So we want there to be new enrichments in the pipeline. We want corrections to upstream models. We want new data sources and all of those things. But at the same time, when those things happen, they can violate some of the assumptions that a downstream system may have had, and in ways that are really difficult to predict. So I think it's very similar to a lot of other engineering challenges. It's just that we don't have as robust tools in many cases for dealing with those very data-centric problems.
Let me piggyback on that and just give a specific example. I think logging is a really good example of this. So, and when I say this, it's this idea that James has tossed out about data systems change and you want them to change. I do a lot of work with companies that have logged a bunch of interesting data, and often it's there either for debugging purposes for the engineering team to make sure software works right. Sometimes it's there for operational purposes, like you have accounting is sort of a log data that can be used for other things. And a lot of the time when you dive in on analytics and machine learning, you're repurposing that log data for something else, right? You're using it to train models or get a window into past user behavior. So there's this data that was originally intended for the purpose of debugging that later on becomes useful for all kinds of other stuff. And so when you go from the original intended use case to all of these other use cases, that's cool because you can make really good use of the data exhaust, but it's also often just really complicated and risky from an inter-team perspective, because the upstream team that's putting all this data in the logs might not even know all the downstream uses that it's being put towards. And it's not as if you want to bind the upstream team into never making any changes. But of course, anytime they make a change, there's a risk that they're going to mess up something downstream.
Yeah, and both of those responses give me a couple of different follow-ons. So one question I have, James, from what you were saying is, have you found that the variability in the source data tends to be greater when you're working with teams that are all contained within a single organization versus when you're consuming data from some external API or data provider?
Well, I definitely think that when you're consuming data from an external API, the more formal relationship that maybe exists through that API is designed to make the changes a little bit more understandable. But I don't know that that necessarily means that the actual downstream system that you're building will actually have less change, because there may be new versions of that API, or more to the point, as you encounter new kinds of problems, or like Abe was mentioning, new abilities to repurpose data. What you, I think, often find is that you're going to still end up having to adapt what it is that you're doing with the API or how you're interacting with it. That said, I think there's another kind of case where we're really targeting with great expectations, which is at the very beginning of a project, as you're evaluating what's out there, I think there's a kind of norming process that a group goes through where what the data sets that each team will provide are getting a little bit more solidified. So, I think of an example recently that happened at the lab where there's a team that is beginning the process of building a model related to the veracity of different news sources. And so they're considering a really wide range of possible features about news sources and a wide range of kinds of models that they'll use. But as they're doing that, they're needing to interact across different people. And in this case, people who have different language skills and are working in different cultures in terms of the different media environments that they're evaluating, and generate data sets or even the processes that they will use to generate those data sets. And that has to be able to evolve very quickly.
And with Abe, what you were saying about logging data, that's something that I'm very close to because I work as a systems and operations engineer. So I've actually been working on building and maintaining a log aggregating system for the past couple of years now. And one of the things that I find to be particularly complex about that type of pipeline is that there isn't necessarily a consistent structure across all of the different systems that you're consuming logs from. And yet you still need to be able to try and unify them all within one storage engine to be able to try and correlate some of the information across multiple systems. And also, as you mentioned, there's a likelihood that the either volume is going to change or the structure of the logs are going to change between different software releases, and new information may be added, potentially even sensitive information. So all of those things add a lot of complexity to being able to manage the system that's actually consuming that information and storing it and trying to gain some useful information out of it. So I don't know if there are any particular types of tests contained within Great Expectations or that are supportable by Great Expectations to be able to bring some manner of sanity and data integrity to systems like that. And then to, from what you were saying, James, ways that Great Expectations can be used to ensure that the source data that you're consuming is matching an expected schema or format.
Yeah. I mean, the question that I hear you asking there is like, where in data science, data engineering workflows is Great Expectations starting to fit in the best? And I hear you bring up logging as kind of one specific example of that. That there are a lot of places you can use it. The place that I see most people kind of gravitating most naturally towards is bringing their upstream data dependencies under test. So the mental model that I have is this directed acyclic graph, right? A DAG with data flowing through it from upstream to downstream. And it, like most data systems, after they've worked for a year or two, they become this complex web of A flowing into B, flowing into C, flowing into D, and all the way through. What I find is that most teams, at least they think they understand the systems that they build and maintain, and mostly they do. And the place where the most fear and uncertainty creep in is at the intersection between teams. So people will naturally start to, as they have the capability to add these kinds of pipeline tests to the data pipes they're maintaining, they'll naturally put it in on the stuff that's flowing into their system, basically as a defensive measure, so that if the format or the structure or the content and distribution of the data that they're consuming changes, they'll learn about that right away, right? They won't learn about it later when it shows up and breaks a dashboard or starts corrupting some downstream model. They learn about it as soon as it hits their system. And then you can go and have a conversation with the upstream team and react to that. We are starting to have some interesting conversations with teams that want to basically get a step ahead of that and use expectations as a way to set up almost an SLA for data quality between teams so that, upstream team A and downstream team B can agree on what the data should look like. And then A can use it, essentially use that specification of expectation tests. They can use it basically as a set of unit tests before they, or integration tests rather, before they publish new systems. And that way, like, Team B never gets corrupt data they have to go back to ask Team A about. It's just always right.
I think, Abe, that point about the way that the integration happens and the way that Great Expectations facilitates the clarification of the roles there is really where I see a lot of value, especially Tobias, as you were describing, even in that log case. I think, anytime you have a log processing pipeline, as you mentioned, when there are different formats, there's got to be some parsing that happens that is intelligent enough to be aware of the different potential formats and probably it's going to extract certain key fields and structure the log data in different ways. With great expectations, you can decouple the parsing logic from your expectations about that parsing logic in a really useful way so that you can have a clear specification of what you want and expect to be present that you can really zero in on because you've been very precise about just what it is. So rather than saying, there's a parsing error, or even if you have a great set of parsing logic that'll throw very intelligent errors, it's still a part of that processing pipeline under that approach. Whereas with great expectations, you're separating that out into an explicit testing pipeline or testing portion of your pipeline that you can use to zero in more directly on where there's a problem, if there is one.
Going back slightly to the concept of why data pipelines are so difficult to test and manage as they evolve too, is that with software systems, you can bring in unit tests and run integration tests with some measure of isolation between various systems. But once you have data flowing continuously through a system, there are bound to be anomalies. And so that brings in the need to actually run those tests in production contexts as well. So that adds another dependency of how the systems are all related to each other. And because data pipelines usually sit in the middle of a number of different systems or a complex web of systems, it increases the dimensionality of concerns that you need to be thinking about as you're writing those types of tests.
Yeah, I think that's exactly right. I mean, one of the key insights that has led Great Expectations to be structured the way it is basically that in data pipelines, just unit testing the code isn't enough, because that the output is the joint product of the input data and the code itself. In a lot of software systems, you have pretty complete control over the code, and that's sort of the only thing that's really changing. So as long as you test the code, you can be confident that you're testing everything that's important. That's just not true in most data systems, right? The data itself can change, and data code that worked really well on data last week might not work on different data this week.
I also think there's a really interesting aspect, that ties into the issues that we're seeing at a strategic level with cybersecurity, where we realize you can't just have a perimeter security approach to really defending a network. I think there's a really strong analogy to data pipelines. I mean, you can't just test the data when it comes into a system and then expect that because you've built your pipeline properly and tested the actual pipeline code, no anomalies will be present. Even more, once there is an anomaly, you really want to be able to zero in on what it is, where it came from, and how it has propagated throughout the rest of the system, which is why it's useful to be able to have those, that defense in depth approach where you're looking throughout the system at many different points to understand how the data are interacting and changing.
Kudos for saying data are as opposed to data is. And so we've been talking a lot about the ways that data systems can evolve and grow this organic complexity that makes it difficult to be able to reason about how the data is flowing or manage how it's being processed. So what are some of the ways that Great Expectations can be used to pay down the pipeline debt and the types of tests that can be run by Great Expectations to keep to control and manage that complexity?
So the core abstraction in Great Expectations is an expectation. And the idea behind expectations is they are a very simple, direct, declarative language for what data should look like. So some of them are things like expect column to exist. So like this, in this table, a column named X must exist. Or expect column to be of type. But we also have things that get into a lot more detail. So things like expect column to be JSON parsable, or expect it to match a certain date time format. And we also have some really interesting things that allow you to do essentially histogram comparison. So expect column, this expectation name is super long. I always forget exactly what it is, but expect column KL divergence to be between.
Bootstrapped.
Yeah, bootstrapped. Yeah, we have these distributional expectations, and conceptually what they do is they let you take a histogram of either a categorical or a continuous variable and verify that future data is close to that distribution. So it's everything from structure to schemas to the actual content of those variables.
And I think that's actually really where people start to have that aha moment of what Great Expectations is giving for you, especially at a level that's a bit richer than just a schema. A schema is great for being able to describe the types of data and the structure that should be there. To some extent, schemas can also, put bounds on data and so forth. And I think those are really powerful concepts, to be sure. But where Great Expectations differs from that is that it also allows you to have, like Abe was mentioning, what we call those aggregate expectations, where you're looking instead of at a row level at a data set, you're looking at an aggregate characteristic of a data set, which may be, of course, a little batch if you're flowing data through a system. It also is a very extensible system. So the abstraction that Abe mentioned, that expectation, is something where we've chosen a language that is very intentionally verbose and precise. Abe mentioned expect column values to be in set, for example. That's the actual name of the expectation that we use. And you provided a set of values that you expect the column to be drawn from. But you can extend that easily. One of the projects that we're working on at my lab, actually, someone wanted to express the expectation about the number of words that were in sentences that were being parsed. And, for her particular analytic pipeline, that was an important concept. And so she was able to, in just a couple of lines of code, add that as a kind of an expectation that she could make. Now, that certainly could have been present as a traditional check in the pipeline itself, but by breaking it out like that, she is allowing herself to get much more precise, diagnostic information about how frequently that expectation may be violated in the data that she's already gotten. But then importantly, as new data starts to arrive, the extent to which that new data is conforming to the previous data sets that she's been looking at.
And that concept of statefulness within these tests is one of the other things that makes it so difficult to manage. And so I'm wondering how you have architected Great Expectations to be able to handle that statefulness within these aggregate tests so that you can, one, make sure that you don't exceed system bounds in terms of memory or disk space as you are collecting those aggregates, but also how you're able to ensure that you don't accidentally drop data or make sure that you're maintaining appropriate context, particularly as you start to scale and distribute some of these pipelines.
That's a good question, and I think our answer right now is probably a little disappointing, which is we've mostly punted on those issues. So the first issue of the first release of Great Expectations was pure Python, and it was just Python pandas. We didn't even support SQL when it was launched. So you had to load everything in as data frames. You had to process it right there in memory as data frames. And that addresses a lot of use cases. But yeah, there's certainly a bunch of issues about like if you're IO constrained or if you're running on really large data sets. That's just not really the way you want to deploy. We now have added on, and this was always the plan, but we've added on core support for SQL through SQL Alchemy. So you can now bind expectations directly to most SQL data systems. We're still working on building out the full library of expectations, but we'll get there. And we actually see a pretty direct path forward to things like Spark and other kind of computation platforms. So for the moment, we haven't really hit optimization and really high degree scalability very hard. But there are a bunch of things that we can do within the framework that I think will support that really nicely when that's the thing that the community is really clamoring for.
I think that's right. I do think that, there are some ways where, there are nearer optimizations that are relevant, things that Abe was mentioning. There are also things that are potentially interesting at a higher level, like looking at the composition of expectations. When we view expectations as a sort of grammar, then we can think of how we might optimize sets of expectations or the evaluation of sets of expectations together. But that said, I also think that there's just something to be said for the simplicity that we've taken right now, because we really are trying to push this to be something where you're thinking of it as an evaluation that happens at batch time. So we're not imagining typically that you're going to evaluate expectations on your entire data center. Rather that as batches of data are coming in or as batches of data are flowing between systems, that the evaluation can happen at those points. I think like Abe mentioned, we're at this point trying to listen to feedback from people who are already starting to use Great Expectations in a wider variety of contexts and let that sort of guide where we need to go in terms of optimization.
And I think, too, that this space is largely unexplored, so any benefit that can be provided even for people who are doing work on single systems or systems that don't necessarily run across distributed clusters, that still provides an immense amount of value where there was a large gap in the availability of tools to help manage that complexity.
I think that's right. In fact, I almost think that that's where there's a greater risk that people are delaying the introduction of tests because they're saying to themselves, oh, this is still small. And so they're not investing up front in addressing that kind of a gap. But I think that's actually a risky strategy. I think it's in many cases better to go ahead and be very explicit about the data expectations as you're building the system so that you can grow into that more effectively.
And for somebody who is first getting started with Great Expectations, what does the workflow look like for starting to build up your suite of tests and then deploying it within the execution framework where the data is flowing through?
James has some great videos on this where he walks you through the process. There are a bunch of different ways that you can approach it, but the one that we see most people using, at least to start, is using Python notebooks or Jupyter notebooks and diving in and using Great Expectations to instantiate a data frame. So it's a one-line Great Expectations.read CSV, just like you would do in Pandas. And in fact, if you use that entry point, we've made it so that the data frame that you get back from Great Expectations, it is subclassed from a Pandas data frame. So it has all of the normal functions that you're used to there. Like you're just in a Pandas notebooks data exploration mode. The difference is that when you dive in, you get this whole other set of methods on that object that are all things like expect column to exist, expect column mean to be between, expect column values to be parsable by date util, and so on. And you can invoke those as you go along. For many of those, you can actually use the function as a quick data check for things like expect column values to be increasing. I actually find our method to be more convenient than anything that Pandas gives you. And so it's a quick way to just verify that the data looks like it should. You run the function, it gives you back true or false. If it's false, it gives you some summary statistics to describe why that expectation was violated. And then as you're doing that, Great Expectations is behind the scenes, building up a log of all the expectations you run. And when you're done with your session, you can export that as a JSON file that has this map of everything that you expect future data to do. So that's what we see as the entry point for most people doing exploration, building up a library of expectations.
That's absolutely right. And I think for me, I think that Great Expectations aims a little bit at having an opinion on this matter. We're not entirely agnostic about the way that you proceed in building a data pipeline or a modeling system. And so I think we are intentionally guiding people toward that very exploratory workflow where they are interacting with a data set and very explicitly declaring their expectations about it and getting direct feedback on whether those expectations are met, so that when you're beginning the process of actually writing the code that you're going to keep for your pipeline or for your model development process, you've really gone through a thorough exploratory workflow and you understand the relationships between the data sets that you're going to be using. And, we're trying very explicitly to guide you toward that kind of a workflow.
Let me piggyback on that and say, when we say guide you toward that type of a workflow, I think it's important to call out how this is different from a typical exploratory workflow. It's like when I dive in, or when I used to dive in before using expectations as a language, I would, bring up my notebook, dig into the data, produce some charts and graphs, and mostly, after I spent a couple hours doing that, mostly what would change is I would then have a notebook full of scratch code that I would throw away, and I would have a bunch of ideas in my head about how the data worked that would fade over time. And there was really no permanent asset from that was useful in the future. You can do some work and make notebooks more useful for that, but because they're hard to call from production and because they're just for various reasons, they're not usually a great fit for really documenting your data well. Yeah, anyway, so that I think of as sort of the before, and the after with Great Expectations is you have this nice set of declarations, right? If you export that file, it's going to be this JSON object that's like kind of big and hairy. But if you scan through the main pieces of it, it's describing exactly what that data object should look like. Like, here are the columns that exist, here are the types that they have, here are the ranges or the regexes that they match, here's histograms for them. And that's sort of knowledge that is documented and reproducible for anybody who wants to come back to it later. And it's machine readable. So if you want to run a future data set against those and validate that future data set, you can verify that this future data conforms to the expectations you had in the past.
I expect we're just preaching to the choir here, but I really think that actually just captures it really well. That notion that if the before is you're throwing away a lot of your code that was the kind of proto pipeline code, the after is that you, when you start the process of writing your production code, are bringing along with you all of that configuration for the expectations that has been built up by Great Expectations, watching the process of you making those expectations explicit in the notebook.
And the fact that you have made the naming for so many of the different built-in tests so long and descriptive, I imagine also helps with being able to reconstruct the context in which you were working when you have extracted those expectations and you're trying to then convert it into a production system, because you don't have to try and unpack some terse variable names or terse function declarations to try and figure out, okay, what is it that I was actually trying to test, because those function names are already very descriptive of the exact steps that were happening.
Exactly right. You really are building the documentation while you're doing the exploration.
And we've been talking a lot about the integration with pandas and some of the numerical Python stack. One thing that I'm curious about is the types of production systems that you're able to integrate with. So I imagine things like Airflow and Luigi would be a natural fit, but is it also possible to integrate with things such as Spark or some of the projects in the Hadoop and Java ecosystem like Uzi or Azkaban?
So specifically with respect to Spark, like Abe mentioned earlier, that's still in the to be seen, or still the coming feature section. But with respect to other kind of job running workflows, Uzi and whatnot, we give you a Great Expectations executable as a part of the package that can take any data set and, well, I should say, at this point, it will take an instantiated data set, so basically a CSV file or a connection to a data table that's already supported, so some SQL supporting store, and it will take a fully formed Great Expectations configuration file and validate that. So, like you mentioned, at that point, it becomes easy to plug it into other workflows, but the constraint is the evaluation context that's available to you, where that data is located.
And if you were to start the project over again, do you think that you would still choose Python as the language for implementation? Or do you think that there are some contexts in which you are not able to use Great Expectations because of that language choice, such as the JVM type systems that we were mentioning?
We would absolutely, hands down, start with Python again. I think Python is just such a ubiquitous glue language that it's a good fit to begin with. And then when you take into account how much work goes on in pandas, I think there's just nowhere else where we could get as much reach and as much impact as quickly as starting in Python.
Agreed.
And have you found that there are any cases where Great Expectations would not be particularly usable or useful for being able to build up a suite of tests or validations within a system?
I've got a few cases. Some of these are things that we want to tackle. So we are in the process of building out expectations, the full suite of expectations to cover SQL. But that's not done yet. And we do get some complaints and grumbling about that. So we know that needs to get done. It will get done. Another one that we've talked about quite a bit and are, I would say, still coming to a perspective on how we're going to deal with it is nested data formats like JSON and XML. So as currently written, Great Expectations basically defaults to tabular data. You can kind of force other stuff into it, but that's not what it's really best at. We're trying to figure out how do you extend that to cover nested data types as well, because there are a lot of data types, a lot of data pipelines that transition back and forth between the two. We were talking about logs earlier, and logs often have this characteristic where you have JSON objects or embedded strings that are kind of semi-tabular but not really. And so like transitioning back and forth between those formats and tabular formats would be really valuable. We don't yet have a perfect way of doing that, but we have a lot of ideas.
And what have you found to be some of the most challenging aspects of building and using Great Expectations and also promoting it?
I think some of the most challenging things that we have come across are just the scope of the ambition in some sense. I mean, we're talking about doing something that I think both really think of as having a place in most every data pipeline related project that we work on. And, I think it can be easy to look at the process of, getting optimization right and working across all of the data contexts in which this would be relevant. And as a small kind of open source project, get overwhelmed at that. But, I think we've instead sort of taken the approach of making incremental improvements based on the things that we and other people who are using the project have as their next step. So, Abe and I are just, very much a distributed team, and keeping the, coordination going has certainly been one of the, really fun but interesting challenges for building Great Expectations.
Yeah, let me echo that. I mean, when you think of what we're trying to do in terms of scope, we've got a system that on the low end is trying to do typing and schemas and kind of data cleaning stuff. So like rules-oriented data cleaning. And at the more complicated end is trying to do anomaly detection on all kinds of different types and different data systems. So like just getting that right, there's a lot that goes into it. So when I look at how this project has proceeded compared to a lot of other data engineering, data science work I've done, it's been very methodical. James and I and other people as we've joined the team, we tend to really hash things out and talk them through carefully and think about lots of edge cases. We do a lot of this in writing in GitHub issues to partly leave a paper trail and partly just make sure we're covering things. And I think that has been the right way to approach it. We've definitely favored architecture and very careful naming and consistency and those kinds of things in this project over slapping a lot of stuff together to get to shiny things quickly. So it's been a very deliberate project. But I think that's right. And I think that we've arrived at a place where it is useful enough that people can start to see that. And we're getting lots of good adoption and, more stories coming back from the field. So I'm excited to see it gain momentum. But like James said, like there's just so many details to get right. Like a thing that we haven't completely figured out is typing, right? So like typing, how do you have one consistent language that describes type in pandas and in every dialect of SQL and in Spark? Oh, and also we want to do this nested data objects like XML and JSON. Like, how do you really think about typing in that world? And at some level, we have to get it right, but it's complicated. There are a lot of moving parts.
I think that we've talked about this notion that Great Expectations is really valuable precisely when it helps to encourage and facilitate communication and clarity of handoff between different teams. But that really is also one of the big challenges, right? I mean, those things are problems precisely because people have different backgrounds and ways of wanting to interact. You mentioned the extremely verbose names that we have for the expectations, and I think that's a great example of that. It's something where people from a software development background kind of cringe a little bit and say, wow, that's so long and verbose. On the other hand, people from a deep data subject matter expertise background maybe look at the statistical tests that we use and say, what does that mean? And so we're really working very hard to try and balance that. And, we have this mantra that we keep bandying back and forth that, explicit is better than implicit. And I think that's really a catchphrase of the project where we are trying to encourage and facilitate communication, which means we have to work really hard on that. And, it's something that is certainly evolving. And I don't know that we've gotten it right and we're done, but I think we're doing a good job at least of paying attention to the right stakeholders that we hope will become good users for the project.
And we've spoken a bit about some of the particular features that you have in mind for future releases of Great Expectations, but in the broader sense, what are your hopes for the project going forward, and what are some ways that the community can help you out in that?
Well, I think one of the things that we're hoping to see is, and we've already been really grateful to see community engagement and pull requests from people who have a feature that they'd like to see. In terms of the design aspects that we see, we've hit on a few of them in terms of expanding the kinds of data sources that can integrate directly with Great Expectations. There are certainly some additional parts of the expectation vocabulary that we'd like to see implemented. We've expanded into multi-column expectations, and we want to increase that vocabulary to make the full range of things that we hope somebody would want to do available. But I also think at a kind of a more maybe one level back, I'd like to see Great Expectations grow into something where it can be used itself as a part of the analytics value chain. So, for example, I'd like to see an ability to have templates of expectations that become a sort of descriptor for data systems so that it would be easier to identify where a data set has come from based on the features, if you will, that the expectations produce when evaluated. That's kind of more certainly a longer term thing. In the shorter term, I think it's just that we'd like to see continued engagement from folks in the community.
Yeah, let me just piggyback on engagement. Specifically, we'd love to hear, honestly, more negative feedback, like, hey, this is not working for me. This doesn't do this. I had too much of a hard time doing that. Because if we can learn about that, then some of those things will be solvable. Some of those things are actually things that we can engineer for. We'd love to hear success stories. So people who are using this and kind of finding new ways to take this tool and put it into practice. Most of my favorite experiences with Great Expectations have been of that type. And then, for those who, the coalition of the willing, those who are ready, if they want to add pull requests, that would be awesome. There are quite a few fairly incremental things that would add a lot to the code base, especially things like building out tests that exist, expectations that exist in pandas but don't yet exist in SQL. Or, that's actually probably a good place to start. So all of those things, more stories and maybe a little bit of code would be awesome things to get back from the community.
And are there any other aspects of the project or pipeline testing or pipeline debt in general that you think we should discuss before we start to close out the show?
Not that I can think of. James, do you have any?
I'm just wondering if we hit enough on the aspect of the complexity carrying capacity. Maybe I'll say Abe and I sometimes talk about what you get by using Great Expectations as an increase in the complexity carrying capacity, which is a bit of a jargony way of saying the ability that that a team has to deal with the interactions that are required as a data pipeline grows. Tobias, you sort of mentioned that notion that there's this n squared complexity that comes when you add a new person into a team, and eventually there are just more and more interactions that have to happen. And I think what we're really hoping is that we can make a difference in the entire trajectory of the way that the cost of dealing with complexity moves forward for teams, so that it's not a matter of putting out fires or changing pipelines all the time when something breaks, but rather that we can have a lot more proactive and well understood processes for handoff between teams, and that can really make the process of adding the kind of complexity that we want, that enrichment, easier.
Yeah, James, that's a really good point. I just to say the same thing from a different direction, every other branch of software engineering has long ago decided that automated testing was the way to go. That if you wanted your code base to get above a certain level of complexity, you had to use automated tests, or there was just no way to hold all the pieces together. And if you didn't, if you neglected your tests and took on that technical debt, then it wouldn't take long before you'd find yourself in this place of just spending all your time running around, putting out fires, unable to refactor, unable to move forward very quickly on features. And it's just, I've worked in code bases like that, and it's not fun. It's just not the right way to do it. I think the core insight behind Great Expectations is data pipelines have not had really a very good notion of automated testing. And expectations provide, as far as I know, the first really coherent framework for doing that.
It's definitely a very important topic, and it's great to see that there's been a lot more conversation happening around the concept of building up those guarantees of how the different components of data systems are going to interact, because there has been historically a bit of a lack in ensuring that there are certain contracts that are maintained between those systems to be able to grow and scale them as they gain these additional layers of complexity. And I think that from the perspective of data engineering, it's been my experience talking to people that there isn't as much of a focus on automation and the idea of pets versus cattle in terms of the underlying infrastructure that's been happening with the systems administration and cloud automation kind of stuff. So it's good to see that there's more of that discussion happening in general across the discipline of data engineering as it becomes a more mature component of data teams and companies in general.
Yeah, that's a good point.
Agreed,
yeah. My wheels are turning in my head on pets versus cattle and how that applies here. That's an interesting bridge.
All right. Well, I appreciate the both of you taking the time to talk to me about this. So I'll have you both add your preferred contact information to the show notes for anybody who wants to follow the work that you're up to or get in touch with you. And so with that, I'll move us into the picks. And this week, I'm going to choose the Fitbit Versa. I picked it up a few days ago because I was interested in being able to do sleep tracking and get some insights into that kind of stuff. And so far, it's been very interesting and enlightening. It's a great device, seems to be very easy to use, and there's actually an SDK for being able to write your own applications for it. So interested to see what kinds of new developments will happen for that. And so with that, I'll pass it to you, James. Do you have any picks for us this week?
All right. Well, I will pick the chance to kind of get away and unplug every now and then. I think that's one of the things that, helps manage the complexity of real life. So my fun this weekend was getting to head out on the lake in a canoe with my two girls, and I encourage everyone to take some time to unplug from all the data engineering that they have to do and get outside and enjoy nature.
Abe, do you have any picks for us this week?
Yeah, I'll put in a plug for my company. That's not usually the hat I wear, but we're Superconductive Health, and we're focused on building the boring stuff. So we're a data engineering team. We're essentially a boutique consulting company focused on ETL, data normalization, data cleaning, data quality, exactly the sorts of things that you run into over and over again if you're building expectations. And we're trying to do all of that better, faster, and cheaper. So if that's the kind of thing that your listeners are running into, we'd love to help out. Let me also put in a plug for a book that I read about a year ago and that has just kind of bubbled up top of mind several times recently. It's called Slack, and the subtitle is Getting Past Burnout, Busy Work, and the Myth of Total Efficiency. It's one of my favorite business books. It talks about why you, actually, James, this goes along with what you said, why you have to have spare time and how that really plays out from an organizational perspective. Why having some slack capacity is just totally crucial. So highly recommended.
All right.
Tobias, I think I have to, if it's okay, I have to give you one more pick and you can choose if you need to. But I think we've been talking a lot about data engineering, because it's the thing that Great Expectations is offering. But if there's a pick of an idea that I have, I think it's that in a lot of the dialogue that I see right now in data science, we're focused on the very, very last mile, as it were, that last analytics step that takes all the data sets that have been curated and developed and chosen and cultivated over time and produces some really amazing results from that, which is phenomenal. But I think it's important when we think about these kinds of projects to realize where the entire value chain has come from, and that as we build in that last analytics layer our greatest new models and start deploying those to great effect, we have to remember the foresight that has come long before in terms of building the underlying collections that have made that possible. There's a project I'm working on right now related to machine translation where we are getting some really incredible results, but they're results that would have only been possible because of the foresight of some other folks years in advance to start structuring data in a new way that made it possible for us to really quickly get that last mile. And that kind of, data engineering work that went well before us is just incredibly valuable, and it creates a value for a long time. So I want to just, plant that reminder to be grateful for all the data engineers in your life.
Shoulders of giants.
Yeah.
All right.
Maybe go with canoeing.
All right. Well, thank you both for taking the time to join me today and discuss the work that you're doing with Great Expectations. And thank you for your efforts in building and growing that library and framework. It's definitely something that is going to provide a lot of value for a lot of people. So thank you for that. And I hope you enjoy the rest of your day.
All right. You too.
Thank you, Tobias.
Thanks so much for reaching out to us.